Hi again, everybody. Chris Tisdale here. Thank you for joining me. In this video, I'm going to continue my series on geometry and geometric constructions. And in particular, I've been using a circle arc template instead of a compass, together with a straight edge, to do all of the constructions that you'll see in high school. Now, one of the motivations for us to put this circle arc template together is because although the compass is very old, like thousands of years old, there are problems with the ease of use. They produce inaccurate drawings and they can be weaponized, they can be dangerous. So this circle arc template is our attempt to replace the compass with something better. So let me show you a construction. I'm going to show you a classic one that you see. It's one of the first constructions that you see in Euclid's Elements, and it's very common in school. The tool that I'm going to use is here. Let me just share my document camera. So you can see this is the tool that we're going to use. You can position the center on a particular point, and you've got this extended arc to trace around. And you've also got a straight edge quite close to it. Now, this tool is part of a bigger template called a Mathemat. And there's lots of interesting shapes in there, lots of interesting markings. But for our purposes, we'll only use this, and you don't need the printed markings on them either, okay? All right, so what are we going to do? Well, I'm glad you asked. So one of the basic constructions that you see in high school is the following. Suppose I've got three points, say A, B, and C, okay? And the two line segments, AB and BC, they meet at the point B. What I would like to do is copy this length, AB, over to BC. So in other words, you know, whatever that distance is, I want to cut it off from this longer distance, okay? Now, how do you do that with a circle arc template? Well, it's not too hard. It would be better if this was exactly the radius of AB or BA, but it's not. But this is not a major problem. So let me step you through it. It's quite an interesting construction, and it involves parallel lines. So let me show you how I would do this. And there's lots of ways that you can do this. Okay, so this is the way that I'm going to do it. So firstly, I'm going to center my circle arc template at B. And I could draw a full 300-degree arc there, but it's enough just to measure the points of intersection and mark those. So we've sort of got two new points here, okay? And you can see I'll go a little bit further with this one. I'll put that on the new point and make a little mark. And I'll put one here as well. Now, the idea is to go the same distance along both of the arms, okay? So you can see this is one radius, this is another radius, one radius, one radius. And whenever I talk about a radius, it's always the same radius, right? Because we're using one template. All right, so we've created a few points there. Let's call these D and E and F and G. All right, so what I can do now, I've got 2 points here, F and G. I'm going to construct a line joining them, okay? And that is going to form an equilateral triangle, an isosceles triangle, because that length is equal to that length. Okay, so let me put that in, say, in purple. And I'll just extend it a bit because you'll see why I do that in a minute. All right, so this is an isosceles triangle. So how do I get this length over here? Well, one way is to construct a line through A that is parallel to AG. And if you remember, I actually did this in a previous video. You've got a given line segment and a point, construct a parallel to the given line segment. So it's the same here. We want a parallel line through A that's parallel to this line segment. Okay, so let's do it. Let me choose brown. And if you haven't seen that video, that's fine, but let me just show you how we can do it. So I'm going to place the circle arc template with center at A, and I'm going to cut the line that we just formed. And I'm going to draw a line or a ray through this one. Okay, so there's a new point. What are we up to? H here. Okay, and now I'll put my circle arc template with center at H, and I'll go down another radius along this brown line. Okay, there we go. So let's call that I. All right, let's get back now closer to this purple line. We will use this point I to form another arc, and that's going to intersect with the purple line. And I'm sort of doing exactly what I did up here. I'm going to draw a ray through this, or an extended line segment. And let's call that J. And lastly, I'll go out one radius along this brown line. And that's pretty much it. There we go. So let's call that K. All right, last thing, let's join up A with K. So let me go to a different color for that one. Why don't we do it in red? Okay, so there's K, there's A. Let's do that. Now, if I extend that, it's going to cut BC at a new point, say L. Let's make that a bit more visible. Now, believe it or not, the distance BA is equal to the distance BL. Well, why? Well, remember this line we constructed to be parallel to this line, right? And this smaller triangle is an isosceles triangle, okay? And essentially what it means is if this line and this line are parallel, the bigger triangle is going to be isosceles. So AB is going to equal BL. But let's prove it, okay? Let's actually justify it. Now, before I do that, let me just summarize what we've actually done here, okay? So we have, oops, actually I might get a better, let me just get a better pen. That one seems to be running out. Yep. So we want to cut off the shorter of two line segments. So the shorter length is AB. From the greater BC. Where the segments meet. Okay, so that's pretty much a summary of the challenge of what we're doing here. Okay, so how can we actually justify this, this construction? Okay, the idea is to show that BA, the length of that, is equal to BL. All right, so we're going to use similar triangles. If you've been watching my videos with the new tool, you'll notice that similar triangle arguments come up all the time. Okay, and so we're basically comparing this smaller triangle, say FBG, with a bigger triangle ABL, and we want to make some conclusions about the lengths, you know, this length and this length. Okay, so let me just summarize that. So you can see the smaller triangles contained in the bigger triangle. These two lines are parallel. So this angle and this angle have got to be the same. Okay, so what have we got? We've got a shared angle down here. We've got two corresponding angles that are equal. That means the third corresponding pair of angles are equal. So by angle, 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 triangle, say FBG is similar to triangle ABL. Right? So what does that mean? Well, it means the ratio of their sides, the corresponding sides, satisfy a certain relationship. Thus, this length divided by this length is equal to this length divided by this length. So let's go up there. So so these are the ratios of the two smaller sides. That's got to equal the ratio of the longer sides. All right, so we're almost done. What is the ratio of this side to this side? Well, it's isosceles. This is 2 radii. That's 2 radii. So this is equal to 1. So this ratio has to equal 1. And so the lengths have to be equal. That's it. Okay, so let me just highlight that because we're super happy. Okay, great. Now, that's the justification. Let me just talk a little bit more about the problem. If this wasn't quite as long, this starting point that you wanted to copy or cut off, you don't have to keep moving the circle arc template around. Maybe 1 is enough, or maybe you need more than 2, but you can move around. And that's one of the beauties of using this tool. You can sort of move it around as much or as little as you want. Okay. Yeah, so that is one of the basic constructions. I like it because it takes something that we've looked at before, parallel lines, and brings it into the mix. So let me know what you think. Have you ever used a compass? Have you had problems? Let me know. I'd love to hear your stories about compasses. And what do you think about the new tool? We hope it is easier to use, it's more accurate, and it's safer. So yeah, let me know what you think. And please join me for the next video on geometric constructions using a circle arc template and a straight edge. Bye, everyone.